Hello friends, this is our second lecture for TYBSc Physics. Subject is Classical Mechanics. In previous lecture, we have already discussed Introduction to Classical Mechanics, and then we have started our first chapter, from which we are discussing the first topic, that is Newton's laws of motion, and already we have discussed about Newton's first law. So in this second lecture, we will discuss Newton's second and third laws of motion with examples in detail. What is Newton's second law of motion? Before going towards the statement of this law, we will see some example. First example is fast running person trying to stop suddenly and he eventually falls down. So you have observed that when we are running very fast, and we try to stop suddenly, then it is very difficult to stop at that instant and one get fall down on the floor. So why this is so? Answer to this question is Newton's second law. Again, second example is a train start to put a brake before the station. Train or any vehicle that you have observed, that if we have to stop, we have seen a speed breaker, then we will put a brake before we reach to the speed breaker. Why this is so? The reason behind this is the momentum of that object. So now what is momentum? Let's discuss about the momentum. Momentum is nothing but a physical quantity used to measure amount of motion in a moving object or a body. This means momentum is the term which will give you the motion in the moving object. That means measurement of motion is done by using this physical quantity which is known as momentum, and this is denoted by small p bar. There is bar over the p because momentum is a vector quantity. This means momentum will have magnitude as well as direction. So momentum is taken as p bar, small p bar, and its formula is small p bar is equals to m into v bar. M is nothing but mass of the object, and v bar, here velocity, v bar is velocity of object. Again here there is bar over the v because velocity is a vector quantity, and because of this our momentum is also a vector quantity. So this momentum is related to our Newton's second law of motion, in which you will get the answer related to these two examples that we have discussed. So let's see what is the statement for Newton's second law of motion. The statement is the time rate of change of momentum of a body is proportional to external unbalanced force, and the direction of this momentum is in the direction of force. This means what? This means the rate of change of momentum with respect to time of the moving body will be directly proportional to the external unbalanced force, and the momentum and the direction of this force, these are in the same direction. Okay, so this is statement of Newton's second law of motion. The time rate of change of momentum is given mathematically as dp bar upon dt. dp bar upon dt, that means rate of change of momentum with respect to time. And Newton's law, second law, tells us that this dp bar upon dt is directly proportional to what? This external unbalanced force. That means dp bar upon dt is directly proportional to F bar, where force is again a vector quantity that we have already discussed in first lecture. So let's see one simple example in detail, then we will derive Newton's second law. There is small derivation for Newton's second law. Now we will take one example. Suppose you are playing a cricket. Everyone has this experience. So you are playing a cricket, and you are working as a batsman. Now you have to do the batting. So now if a cricket ball with high momentum. Now here the term high momentum means what? Now momentum is what? Measure of the motion. So if there is a high momentum, this means a cricket ball is with a high speed. Cricket ball is having a very high motion. That means a cricket ball with high momentum if comes towards you, and you have to do the batting. So you have to hit that ball with your bat. So that means you are hitting the ball. This means the ball will come with specific high momentum, and you are hitting the ball. This means you are changing the momentum of that ball. Okay, so in next line we have discussed this, that now you have to change the momentum of a ball, for which you will need to apply high force. Now why you will need high force? Newton's law tells us that the time rate of change of momentum is directly proportional to external unbalanced force. Means the rate of change of momentum, if it is high, means ball is having high momentum, and you have to change that momentum. Then to change that high momentum, you will also need a high force to your bat that you have to apply. Then only momentum of a ball will change. That means then only you can hit the ball. Otherwise you can't hit the ball, and there is a chances of your wicket. So if now in second case, let's say if ball coming towards you is having low momentum, then eventually you will need what? Low force to change that momentum of a ball. That means to hit the ball you will need a small force, because ball is coming with a low momentum. So that's why the faster bowler, it is difficult to bat the faster bowler. If ball is there is a slower bowler, or ball is coming with low speed or small momentum, it is easy to hit that ball, and we will get the sixer or four. If it is high momentum is there for a ball, then there are chances of your wicket. So in order to give high momentum, that's why there is a reason why bowler come from long distance than the desired one, because in order to give higher momentum to the ball, bowlers start to run from a longer distance than the desired one. Okay, so this all explanation implies me that the amount of force required to change the momentum of object is directly proportional to the rate of change of momentum of the object. Means if you have to change the momentum of object, that force you will need will be directly proportional to the rate of change of momentum of that object, and this is nothing but the Newton's second law. And Newton's second law mathematically written as F bar, that is force you need to change the rate of change of momentum, or to change the momentum. This force, external unbalanced force, is directly proportional to dp bar upon dt, where this p bar, now what is p bar here? P bar is a momentum, and that is nothing but m into v bar. So in order to remove this proportionality sign, we will need some constant that we have taken as a small k. So we can write F bar equals to k into dp bar upon dt, and now we have to put this value of p bar in this equation. So what will we get? Now see, if I put value of p bar over here, p bar is what? M into v bar. Now mass of object will remain constant, and what will change? Only velocity is changing. So I can take mass outside the derivative. So F bar will become what? Km dv bar upon dt. Okay, is it clear? So here we have substituted value of p, and we have taken mass outside the derivative, because it is constant with respect to time. With respect to time, mass of object is not changing, so I have taken it outside the derivative, and my equation will become F bar equals to Km into dV bar upon dt. Let's say this is our equation 1. We will need this equation, so you have to note down it. This is our equation 1. In next step, we will put this as a some quantity, so you will need this equation. That's why I call this as equation 1, where K is what? Constant of proportionality. Now we can take this constant, that is K, as a unity by defining unit of force which is produce unit acceleration to the body of unit mass. This means if we are taking K as a 1, that is unity, then there will be unit force which produce unit acceleration to a body of unit mass, means everything will be in a unity. So by substituting K as 1 in equation 1, this was our equation 1. So I am going to put value of K. I can take this K as 1 if I am taking mass with 1 kilogram of object having mass 1 kilogram and acceleration is how much? 1 meter per second square. Then this is produced due to what? 1 Newton force. Then I can take K as 1. So I am going to put K1 in equation 1. So we will get F bar is equals to what? M into dV upon dt. So in above equation, you can observe that the rate of, here there is rate of change of velocity with respect to time, and you have already studied in your 12th standard or in FY also you have studied that rate of change of velocity with respect to time is nothing but acceleration. Means we can substitute the definition, we can use the definition of acceleration, that is rate of change of velocity with respect to time in above equation. Then we will get F is equals to M into A, or F bar, because this is vector quantity. So F bar, that is force, will be equal to M into A bar, that is mass into acceleration, and this I am going to call as the equation 2, and this is known as the Newton's second law. So this is mathematical equation. So Newton's second law is represented mathematically as F bar is equals to M into A bar, or force is equal to mass into acceleration. Now here F bar is force and it is measured in Newton, and this Newton is what? SI unit of force. So we can define 1 Newton. So what is 1 Newton? We have to define 1 Newton. Then in, if on LHS, if force is in Newton, then the quantities in RHS should also be have same units. That means if force we have to define as 1 Newton, then on RHS there is M into A, that is mass into acceleration. So if you are applying 1 Newton force, then mass of the object will be 1 kilogram and acceleration will produce in that body will be how much? 1 meter per second square. This means if you have to apply a force or you have to accelerate a body having mass 1 kilogram with acceleration 1 meter per second square, then how much amount of force you will need? You will need 1 Newton of amount of force. Okay, so let's define what is 1 Newton. 1 Newton is the amount of net force that gives an acceleration of 1 meter per second square to a body with a mass of 1 kilo. Okay, this means what? If you have to accelerate a body having mass 1 kilogram with acceleration how much? 1 meter per second square. Then you will need how much force? 1 Newton amount of force, and this is definition of 1 Newton, that is 1 Newton will be equal to how much? 1 kilogram meter per second square, or 1 kilogram into 1 meter per second square. This will give you how much? 1 Newton of force. Okay, now let's discuss some quantities related to mass. Okay, so now suppose I am applying a constant net force to a body having mass m1, and that mass we are, that amount of mass is known to us. means m1 is known to us. So let's say I'm applying force F to a body having mass m1, and due to this the acceleration is produced in that body, which is a1. Okay, now the same force I am going to take, and I am going to take another object with mass m2. Now suppose I am having another mass, another object which having mass m2, but I don't know what is value of m2. In previous one we are taking a body with mass m1 and value of m1 is known to us, and we are applying force F, and there is production of acceleration, that is a1. Now I am taking a body with mass m2 and m2 is unknown to us, means we don't know the value of m2. So we are going to calculate this by using some mathematical terms. So mass m2 that is produce an acceleration a2, means I'm applying same force F that already I have applied to body m1. So from Newton's law, second law, we are having force is equal to mass into acceleration. Now we are having two objects m1 and m2, and acceleration of those objects are a1 and a2, and I am applying same force. This means I can equate the both forces on the object. So I can write m1a1 equals to m2a2. Okay, here I am taking only scalar part for my sake of convenience. You can put here bar also, meaning will be same. Meaning will be what? It, you are representing it as a vector. Okay, so now I am taking two objects having mass m1 and m2, and acceleration produced in those objects are a1 and a2 by applying same force, which is F bar. So I can equate both forces, that is m1 a1 will be equal to m2 a2. Okay, so from this I can rearrange this, and I can rearrange it like I'm taking this m1 over the RHS and take this a2 over the LHS. Then what we will get? m2 upon m1 equals to a1 upon a2. So from this, now it is unknown to us. Which quantity is unknown to us? m2. So from this I can calculate m2. So this implies me what? I can calculate m2 as m2 equals to a1 upon a2 into m1. And see, you can observe this equation. Here there is m2 upon m1, but on RHS there is a1 upon a2. Okay, so this implies me that ratio of masses is the inverse of the ratio of acceleration. Okay, if we took ratio of masses of two objects, then that will be reciprocal of ratio of acceleration of those both objects respectively. And from this Newton's second law, I can calculate unknown mass m2 as a1 upon a2 into m1. Okay, and the mass which is calculated in this way is known as inertial mass. So mass of a body measured in this way is called as inertial mass. Also another way of measuring the mass is by weighing. So you can measure the mass of object by weighing it by using weighing machine, and weighing machine works under Newton's second law. The working mechanism of weighing machine is nothing but it is based on Newton's second law, because in the gravitational field the weight of object is or weight of body is exactly equal to the amount of gravitational force acting on that object. This means if you have to measure mass of any object, that object is taken or that object is studied under the gravitational force, means gravitational force will act on that object, and that is nothing but the weight of that object. How? Let's see. From Newton's second law, we are having force is equals to mass into acceleration. So here this force, if the acceleration is due to gravity, means acceleration in the object is if due to gravity, then this force will become as a weight. That means F, instead of F you can say here W. So weight will be equal to m into acceleration is taken as g, that is acceleration due to gravity, and you know the value of g. What is g? 3.8 meter per second square or 380 centimeter per second square. That is nothing but gravitational acceleration. So there are two ways of measuring the mass. First is what? Inertial mass, that we have already discussed, and second is what? Gravitational mass. Okay, so this is known as the mass which is measured under the gravitational field or gravitational force when acts on the object. Such measurement of mass is known as gravitational mass. Okay, so this was all about the Newton's first law. Now let's discuss about the Newton's third law. In Newton's third law, we will see some example first. For example is when one throw a ball on the ground from the top, then it gets bounced back towards us. Now why this is so? Answer to this question is Newton's second law. So let's see why this is so. So it is due to action and reaction forces, which is discussed in Newton's third law. So let's see the statement of Newton's third law. Newton's third law tells us that for every action there is equal and opposite reaction. Okay, so this is statement for Newton's third law. So let's go back to our example, that is when we throw a ball towards the ground. Now ground, that means the second object is earth. Okay, we throw the ball on the ground. Here ball is our first object and ground means earth is nothing but our second object. So when we throw a ball towards ground, that ball will get collide on the ground. So when there is collision of the ball on the earth or on the ground, that ball will exert some force on that ground. Okay, and that force is known as action force. Okay, we are throwing the ball on the earth or on the ground, then ball will exert some force, because we are throwing ball means ball is in motion, and from Newton's second law, rate of change of motion is directly proportional to force. That means due to momentum, ball will exert some force on the earth. That force is known as action force. Now second is the ball is collide on the earth. This means now earth will also exert equal amount of force on ball according to Newton's third law, and this force which is exerted by earth on the ball is known as reaction force. There are two terms, one is action and second is reaction. Action and reaction, action force and reaction force. So what do you mean by action force? In this example, force exerted by ball on the earth is action force, and force exerted by earth on the ball will be reaction force. Okay, so now question is that ball will come return to us. Why earth didn't get downward, pressed downward or pushed downwards? The reason behind this is discussed in below statements. Okay, so question is what? Why only ball get bounced towards the earth? Means ball will get bounced back towards earth, but due to ball there is no reaction on the earth. Earth will remain as it is. Due to ball there is no change in earth position, or because of a force, that is action force exerted by ball on the earth, earth didn't get pushed downward the direction. Why this is so? So again, answer to this question is Newton's second law. Let's see it. What is Newton's second law? Force is equal to mass into acceleration. So let's discuss. See now here, force is equal to mass into acceleration. This means if mass of object is large, then force exerted by object will also be a large. See this statement, F is equal to mass into acceleration. This means force is directly proportional to mass. If mass of object is large, then amount of force exerted by object will also be a large. So in this case, mass of ball is very much less than mass of earth. Okay, this means what? This means force exerted by ball on the earth will be very much less than force exerted by the earth on ball. Means action force is very much less than reaction force. Okay, and due to which, this is the reason due to which the only ball will get back bounce towards the earth and not earth get pushed downwards. Okay, so this is reason because of which there is the reaction force is greater and action force is smaller. That's why there is ball get rebounds towards the earth. And there are few some examples, that is boating. You have already experienced, I hope all of you have did boating. So in boating also, the water and boat, there is action and reaction force between water and boat. So due to which your boat will move in forward direction, that is the reason or mechanism in which your boat will move in forward reason. And another is firing of gun. If a person is firing a gun or a revolver, so uh, person is shooting or firing the gun, so because of fire there is again action and reaction force. So action force is what? You are firing the gun, and reaction force means gun will push your hand or your shoulder towards the back side. So these are few examples of Newton's third law. uh, this is all about Newton's second and third law. Till this lecture, we have discussed introduction to mechanics, Newton's first, second, and third law with their examples in details, few derivations. Okay, and in next lecture, next point will be continued. Thank you.